Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is binary love. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. Alice and Bob are playing a game on a binary string S of length n. Now Alice wants to make the number of substrings 0, 1 and 1, 0 equal, and both counts must be non-zero. Now formally, let C01 denote the number of indices I such that S of I is 0 and S of I plus 1 is 1. And similarly, C of 10 denotes that S of I is 1 and S of I plus 1 is 0. Now Alice would like that the C01 is equal to C10 and their count is both non-zero, that is greater than 0, and both the conditions should hold. Now Bob, on the other hand, wants to prevent Alice from achieving this condition. The player takes turn alternatively, with Alice going first. In each turn, the current player can remove exactly one character from either the beginning or the end of the string. The game ends immediately when the string becomes empty or when Alice's desired condition, that is, C01 and C10 both is equal and greater than 0 is satisfied. If Alice can make the number of 0, 1 and 10 subsequent equal, she will win. Otherwise, if Bob can prevent this condition until the strings become empty, Bob will win. In particular, if the initial string satisfies the condition, Alice will win immediately without even having to make any move. Now we have to determine winner of the game if both of them will play optimally. So for the input format, we have t test cases, and for each test case we have two lines. The first line is the integer n, that is length of the string, and the second line will have the string itself. As for the output, we have to print the winner's name, Alice or Bob. As for the constraints, number of test cases and length of the string will go from 1 to 2 into 10 raised to 5. Let's see some sample inputs. So for the first samplet, we can see that the string contains only zeros. And as it stands, the count of 0, 1 and 1, 0 is equal, that is they are 0, but they fail the condition that the count should be greater than 0. Therefore, Bob wins. In the second sample input, the string is 0, 1, 0. We have one substring of 0, 1 and one substring of 1, 0. Therefore, the count is equal and it is greater than 0. So by default, without making any move, Alice wins. Let's see how we can approach the solution. So first, let's see when do we get 0, 1 or 1, 0 substrings. So let's say we start with 0. If we start with 0, the next character is again 0, no substring is found. If we add 1, we get the 0, 1 substring. Now from 1, again if we add more ones, we do not get 0, 1 or 1, 0 substring. But the moment we change to 0, here we go, we get the 1, 0 substring. It means that whenever we are changing characters, we get the substring 0, 1, and once we change, it gets 1, 0. It means that in a string, whenever we have 0, 1 or 1, 0, that is greater than 0, right? If both of them are greater than 0, then it would mean that either their count is equal, that is C01 is already equal to C10, or it will differ just by 1, right? This will be the case. So it means that whether we remove any character from left or right, if you see in this case, when we delete 0 from here, the count of the substrings will not change. But if we delete it now, the count will change, but it will only decrease by 1. So it is only possible on removal that either nothing changes, if we remove something, then it decreases by 1. Now in that case, if the count of C01 or C10, if both of them are at any point in the start greater than 0, then Alice will always win, because while deletion there will come a point when we remove a character and the count becomes equal, and at that moment Alice will win. But from the start, if the count of the substring C01 or C10, if any one of them is 0, it means that Alice will always lose, because we can remove it. We are not adding. So we cannot add the substrings, we can only remove it. So in this manner, if C01 is equal to 0 or C10 is equal to 0, then the winner will always be Bob. Otherwise, winner will always be Alice. And with this, we get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and then we take the input of our string s. Then we find the initial count of substring C01 and C10. If any one of them is 0, Bob will always win. Otherwise, Alice will always win. And as you can see, I've got an EC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take input of n and the string s. We get the initial count of subarrays of 0, 1 and 1, 0. If any one of them is 0, then Bob will win by default, otherwise Alice will win. And as we can see, I've got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.